Hello friends, my name is Devansh Gupta and you are watching the Shareef Coder. So in today's video, we are going to discuss about a famous database known as Redis. So Redis is a in-memory data store. So what does it mean by in-memory and what does it mean by data store? By in-memory, we mean that all the data would be stored in the RAM only and not the secondary storage like SSDs or HDDs and other sort of persistent storage mechanisms. And because we are storing all the data in the primary memory, the data access is blazingly fast because you just have to look up in your memory and not have to wait for disk IOPS or network IOPS to be done to access your data. Second is data store. So it is a database, and it can be used as a Swiss Army knife. So it is not a relational database or a NoSQL database. It can use as a graph database as well. It can use as a NoSQL database as well. It can use as a geospatial database as well. So it is a Swiss Army knife of databases. It provides you a client server model. The client would be your Redis clients and the server would be the Redis server, and it can be a cluster of Redis nodes, and the client and server can reside on different networks. You just need to have the remote access to that server and you can access the database. So it have a sort of APIs you can use to manipulate your data, do some operations, delete data, add data, do all the CRUD operations, expire keys in the memory. And so today in this video we would go through the basic commands Redis exposes by its command line tool, and in the coming videos we would deep dive into this architecture of Redis, how these commands are internally functioning. But for now, let's get into the Redis commands. So for this video, I'm not going to show you how to install Redis on your device because that can vary on system to system, that the process would be different for Linux, Unix and Windows. So I will drop a link to a tutorial from the Redis guys that would help you to install Redis in your system, whether it is Linux, Unix or any sort of operating system. So in this video, I would just simply invoke the Redis CLI, and that is the Redis client that would connect to the local Redis server that is installed on my system. To connect to your Redis server, you would use this command Redis CLI, and it would take the server address. Because my server is on localhost, I would enter localhost and it would connect me to my localhost Redis server. If your server resides on a remote address, you can enter the domain name of that server or the IP address or the whatever kind of address you are using to name that server. So let's deep dive into the commands of Redis. So the first command we would go with is set command. The set command would take you two things, a key and a value. So the key would be A and the value would be red. Okay. So now if I want to access what is inside this key A, I would run this command get A, and that is red. I can send another value correspond to this key A, say this time yellow, and yeah, it's yellow. Now you are saying you might be seeing that the set command has a couple of more options. We won't dive into those options because it might confuse you. We would go through these arguments in another video. For now, what I bring your attention is the expire command. So in Redis, whenever you store a data, it would going to live forever in your computer's memory, but that's a bad thing. For example, if you have a heavy load on your system, after some time your RAM would be overloaded, would be exhausted. Then Redis would automatically starting discarding some of the keys because it wants more space for more data. So to mitigate this problem, we can expire our keys after a certain time. After certain time, it would be automatically wiped out from your Redis memory, and that we can do is with the expire command. Before expire command, I would show you the TTL command. TTL means time to live, so it returns you the seconds has left in the life of that key. So TTL for A is -1 because we haven't set any expiry date for this key. It would remain in the memory forever. So let's set expiry date for this key a. So the command would be expire a and number of seconds we want it to live. The seconds would be started from the moment you invoke this expire command. So let's see if what would happen if I set this to 30 seconds. Now the a would live only 30 seconds. Only 25 seconds are left in the life of this key a. Let's see the value of this key a, that is still yellow, and now the TTL is 16 seconds. So 16 seconds has left. The value is still yellow. TTL is 4 seconds, and let's wait for 4 seconds. Okay, now it is -2. -2 means the key has been expired. Let's see what is inside this key a. Nothing, because Redis had discarded this key, so you won't find anything. So this is the mechanism Redis provides you to automatically expire your data after a certain time, so Redis can save some memory for new data. And you should also plan your Redis caching strategies around this expiration strategy that Redis provides you. So now we are going to see another data structure exposed by Redis, that is lists. So lists are nothing but doubly linked list implemented by Redis, and let's see the commands. So the first command would be the lpush command. Lpush command would push a new item in front of the list. So the list is L and the value would be say 1. Okay, to get the length of the list we can use this command length, len. So now we have only one item in this list. So if I use this command lpush again, and now I would enter 2. So 2 would be pushed in front of 1 because it is a left push. Okay, so you are pushing data from the left of the list and not the right. So let's see how items are aligned in the list, and for that we can use this command lrange. So lrange would take you 3 arguments, that is the key for the list, that is L. Starting index, so because it is computer science everything starts from 0, and the stopping index. The stopping index would be can be the length of the list. Okay, or if you don't want to invoke this length command every time to see how many items are there in the list and then you would invoke them with this lrange command, you can simply use this special index -1. This -1 index would automatically calculate the iterate the whole linked list for you. So the lists have 2 items, 2 and 1, and 2 has been pushed in front of 1. Okay, because it was a L push. Let's see if we do an R push. So we have an R push. So R push would append anything into a given list. R push is L and the value is say 3. Okay, now let's see. So every time you enter any command L push or R push, it would return you the length of new list. Okay, so in this case it is 3. For just formality I would again run this command length and let's see how many items are there. So it's 3, and now let's see how they are ordered in the list. That is L0 - 1. Okay, so 2 1 3. So 3 is pushed behind the key 1. Now we have another commands like lindex. So lindex can be used to invoke any item on a certain index. So the index for this item 2 is 0, and for 1 it is 1, and for 3 it is 2. Okay, so let's find what is at index 2. Okay, so the answer should be 3. Yeah, it's 3. Let's see what happens when you enter a wrong index that doesn't exist. Okay, so the index that doesn't exist is 5. Okay, it should give you a null because nothing resides on this index. Okay. Now we have a command called lpop. So pop would just simply discard anything, the first element from the front of the list, and it would return you that item as well. So as we have this list as, okay, that's my bad. Yeah, L range L0 -1. Okay, so if I want to do an lpop, the 2 would be discarded because L would read the list from left side and it would discard the first item it sees, and it would return that item. So lpop L would return you 2. Now the list has only 2 items, sorry, my bad, 1 and 3. And if I run this command rpop, it would discard 3 because rpop would discard anything from behind the list and would return you that item as well. So let's go with rpop L, yeah, 3, and now the length of this list is 1 again, and the items have only, my bad, I don't know why I'm forgetting the list name every time. Okay, so it's only 1. So that are a couple of commands exposed by Redis to manipulating lists. So you can use these lists in whatever manner you want. If you can use them as a queue or a stack, or like any sort of ADT you can make out of these simple data structures provided by Redis, be it as a list or a string that is manipulated by get and set commands. Now let's dive into my favorite Redis data structure, that is hashmap. So hashmap is like a regular hashmap provided by languages like Golang and Java. So let's see how commands work for hashes. So the first command would be the hset command. Hset command would ask you for a key, field and a value. So hashmap, we would use a key name h, the field would be name, and the value would be Devansh. Okay, now to get this value again from this hashmap, we can use this command hget. Now hget would only ask you for one field and it will only return value for that field and not for the other ones. Okay, so h is the name of the hashmap, the field name is Devansh. Now if I want to add age field in this hashmap, I can set with hset h age, and that is 23. Now if I want to get all the keys inside this hashmap h, I can use this command hgetAll, that is this. So now for Devansh the value is, so for name the value is Devansh and for age the value is 23. And now if I want to get the length of this hashmap, I can do that with this command hlength, that is 2, because I only have 2 attributes, name and age. And if I want to get only the keys of this hashmap, I can use this command hkeys, that is name and age. If I want to delete a key inside this hashmap, I can use this command hdel. Okay, so hdel would ask me for the hashmap key and fields I want to delete. So for now I only want to delete only one field, and that is say age. I don't want my age to be exposed. Yeah, that is, it's deleted. Now let's check what the keys are left inside our hashmap h, and its name only. So these are some basic keys by hashmap, by Redis hashmaps. So in this video we explored some of the core data structures provided by Redis, that is strings, hashes, lists. But Redis has a couple of more data structures like sets, sorted sets, hyperlogs, and bit fields, but we would explore those data structures in some another video. For this video, I'm just want to say please subscribe, comment below the video, and if you want any kind of different content, please let me know in the comment box. And that's it from my side, guys. Stay happy and keep smiling.